page. And just to give us a quick review today is go over sort of the basics of JavaScript again. So this is going to be much faster. This is going to be just a review of a lot of the concepts of it. And then I'm going to give you a resource. And I'm debating whether it'll be like for next class that I want this or the one after potentially, because I might have you do some HTML work before the next class so that we can do more hands-on in the next class, talking about what you've done. But I'm going to go over the material the sort of JavaScript that we already learned in class from the class that we had. And then what I'm going to encourage you guys to go through afterwards is I'm going to send out this modern JavaScript cheat sheet as a reference. What this is going to introduce you to is a lot of different syntax for JavaScript. Some of it we talked about and some of it we didn't really talk about in class because it's sort of newer syntax or newer style. But it's things that you're definitely going to encounter as we're working through React. So I'll give you a quick example, and then we'll jump over and look at the JavaScript, review that we have. But some of the stuff that we just sort of touched on in our last class, but we didn't really go into detail on, was we did variable declaration, and almost everything we did was using var to declare our variables. But I did mention, there's also a couple other ways to declare them. You can declare them with const and let, and these are two newer ways to declare variables in JavaScript. And you'll run into those examples, that style, a lot in React code. And so you're going to at least need to have some sort of reference, something to go back to use as a reference when you encounter it to say, what does this mean again, and how is it different than what I'm used to seeing with var? So I'll be sending this out after class so that you guys can go through this yourself. Some of it's definitely going to be more challenging than anything you've probably encountered, because there'll be mentions of things like promises, which are a pretty complex topic. I'll be honest with you, I don't fully understand promises. Every time I try and deal with them, they're a challenge for me. So I'll expect other people would probably struggle a little bit with it, but there's still topics that you'll end up encountering as we do React work. And it'll be good to have as a reference. But let's start off with just reviewing more basic JavaScript syntax. So this book I'm using right here, I can also send this out, but it's focused on, there's more generations in this, but you can think of JavaScript as having two major generations, if you will. There's ES5, because JavaScript is actually known as ECMAScript. And ES5 is mostly what I taught in the last class. It's the JavaScript that's been around for a long time and has sort of people are comfortable with. And then in 2015, is when it finally got standardized, was what was known as ES6. And this added a bunch of these new features. So like that const and let version of declaring variables and stuff like that. There's a whole bunch of new that got added in ES6. And it doesn't change the meaning of any of the old stuff. It just makes a lot of things easier to work with. It gives you some new methods and stuff. So this book, this one that I've got right here, is I think completely ES5. So it's mostly the older syntax. And then that modern JavaScript reference will be focused more on the ES6, learning how some of that has changed to make things easier to work with. So, like I said, this will just be a little bit of a whirlwind. I didn't read through every section of this, but the guy who wrote this is whatever. He's at the core of building the language as a whole. So it's going to be one of the best references that expressions. We didn't talk too much about this in class, but there's a little bit of a difference. Yes. Bigger still? That better? Yeah. All right. No problem. So statements do things essentially, and we did discuss statements, right? Writing out statements. And expressions are just something that produces a value, and then you have to do something with it. It's not very often that you're probably going to need to know the difference between the two, but it's just useful. Statements in particular, it's useful to know about. Like anything that's taking an action somewhere, that's a statement of some kind. So this is an if statement because it's doing something. It's deciding where to go. We talked about semicolons. They go at the end of every line when you're writing JavaScript, or at the end of each statement in a sense, I guess. But they're not totally required, but I'm just going to say for class sake, for your guys' sake, just always use semicolons so that you don't have any confusion. If you run across code that's not using it, just realize that they're not doing something necessarily wrong. They're just using a different syntactic style of JavaScript. Comments are simple, right? We've worked with comments a lot. You just put comments in your code to help explain what's going on. There's two different types of comments in JavaScript. There's this sort of double slash, which can go after a line, or it just means the rest of this line after this is a comment. Or you can have the multi-line style comment, and that starts with /* and ends with */, and anything in between those two sort of bits is a comment. It doesn't matter how many lines you have. So variables and assignment. We should be pretty comfortable with this at this point, right? We're used to creating a variable or declaring a variable, var, foo. And we're used to assigning values to variables, right? Very simple. So this is just an assignment statement where we're assigning 6 into the variable foo. And then you can change it as well afterwards. So, or instead of 6, because we changed the value that is. And people can stop at any time if they have questions or want to review or aren't clear on something. So just put your hand up, let me know, and we can go into stuff in more detail. Compound assignment operators, we didn't really work with these too much just because I was trying to keep things simple when we did our previous class. These are a nice shorthand. This is because programmers are lazy. And so we don't want to have to type things out if we don't have to. So we would have written stuff out x equals x plus 1 to do anything that was adding 1 to x, right? Well, you can also, there's a shorthand notation for that, which is x plus equals 1, which is just a lazy way of saying x equals x plus 1. The plus equals is a sort of common shorthand in just about every programming language that lets you not have to write out that you're taking your value, you want to get the value and add something to it on the other side and then assign it back to that same variable. So this could have been x plus equals 5, and the equivalent of that would be x equals x plus 5 down here. Any questions on that?
It works with all the math functions or math operations.
I think it does. I don't know if I've tested them all. I mean, we could. Do I not have a? Maybe I don't have a. This. I make this much bigger. Whee! All right. Oh, you know what? I'm not working in here. I want to work in the same environment as you guys when I'm working with stuff. So here we go. Inside of Cloud 9. Let's just fire up Node and try it. Our foo equals 12. Foo divided by equals 4, right? So foo should be 3. So yeah, it looks like it probably works with everything. You know, plus and minus are the ones that you most commonly use it with. And so I don't know if I've actually ever used them with division or multiplication sometimes, but plus and minus are definitely the most common ones to use that with. So we talked a little bit about identifiers in class. This is mean something in your code. So they're names that play various roles, right? We're used to, it's a little hard to explain to me. I don't know if it's just me that has struggles with this or not, but as you're building up a program, you start with your reserved identifiers or reserved words, and those have meaning in the language. So those are if and var and while and all of these special words that the language knows that they have a meaning. And then as you add in, like create variables, those sort of get added to your list of things that have meaning farther down in your code, just a different type of meaning. And all of these are, one of the things important for JavaScript is they're all case sensitive. So it matters that your variable foo is lowercase f versus uppercase f, as they're not the same. But this is the list of, and you don't need to memorize this. This is just the list of words that are reserved in JavaScript. So that means that you can't use them in your code directly because they have existing meaning, or they intended at some point to give them meaning. There are a few words in here that were reserved early on in JavaScript that didn't really have any meaning, but they locked them down and said this is going to have meaning at some point. And they ended up not giving it meaning right away. And then here's 3 other identifiers. As it says, these aren't reserved, but they're close to. And the reason they say they're not reserved is, like, let me give you an example here of the dangers that this could pose. So if I did something like, oh, I'm not in Node anymore. Let me come back in. So if I did, should my computer just slow now? You can see that that didn't like assign a variable or anything there. It had sort of a problem, but if I did foo equals 5, it assigned a variable. And the reason for that is because case is a reserved, let me zoom in more still, so this will be larger. I can go even larger right now at least. Because case is reserved, so I couldn't say case equals 5 because it's trying to do something with that case. It sees that word, says, oh, this has some meaning, and trying to work with that meaning, but equals 5 isn't what the meaning for it is. And that's sort of what it means by it's a reserved word. But then you have ones like undefined, which it said isn't reserved, but you should treat it as such. And the reason for that with undefined in particular is because JavaScript has a little awkward quirk. Undefined does have meaning. It means that it's something is undefined, but you can actually sort of mess up the language by reassigning undefined. If anything later on compares against undefined, it's not going to cause any problems right now. I don't know why. I'd probably have to set this up in an actual environment. They probably safeguard against it in this node space. But you can actually reassign undefined and then mess up the meaning of that symbol. So you should treat it as another thing that you can't assign a value to or can't work with like that. So values. As it says here, JavaScript has many values that we've come to expect from programming languages. Oh, I'm gonna scroll up real fast. Let's ask the question I asked a lot of times in the last class, and people may have forgotten some of them. Do people remember what the different value types are in JavaScript? What types exist? Objects. Numbers. Null, Boolean. undefined, and it might be all. We had strings. I might be missing one, but yeah, I think we've captured most of them now, right? So those are essentially all the different types of values that we have. And I don't know if he'll talk about that here, but it's useful to think about that. So one of the interesting things about JavaScript is all values in JavaScript have properties. Each property has a key or name and a value. This is like, this ties back to objects in a sense. And so that'll, you begin to start thinking of almost everything with sort of this object type approach when you're working with it. So here we have a string. Var string equals ABC. Well, that's just, you'd think, okay, all I have is a string of some kind, and the value of it is ABC, but it also can have a property of length. And we did that a lot in our last class as well. We worked off with the length of the string. And to show you that it doesn't magically come from being a variable or being assigned to a variable, JavaScript, if you did quote abc.length, will also give you 3 because it processes this, sees that it's a string, and a string has a length property. So you can get the length right off of that string directly. And then you can also use it to assign a value to a property. So if you have an empty object, again, this should be, syntax is pretty familiar with us from the last class. For people who haven't worked in JavaScript as much, it might be something new. But the empty object is just curly braces side by side. And then you can assign values to any property on it. So you can do .foo equals 1, 2, 3, and then if you read .foo off of it, you get 1, 2, 3. And the values don't have to be just types like strings or numbers. The values that you can assign to properties can also be functions. So you can have functions or even methods or whatever that you assign to properties on your different objects and then invoke those directly. And we're gonna go through that a little more through these examples, but any big questions on that? Just the ability to assign values to properties on pretty much any object in JavaScript. All right, so next we have JavaScript makes a somewhat arbitrary distinction between values. The primitive values are, and this is what we all just rattled off, right? We've got Booleans, numbers, strings, null, and undefined. All other values are objects. And this is where there can be a little bit of confusion. We said an array, for example, and there is some distinction about what an array is, but an array is also just an object in JavaScript. At the most basic level. You can find out that it's an array. There's methods to do that, but it's really an object, just a specific type of object. And then, I don't know if people remember the conversation we had but around this, but when you're comparing objects, or when you're comparing values, I guess, there's a difference between object comparison and comparing any of the primitive types. And that's the idea of identity or pointing to the same thing. Some people call it comparison by reference versus comparison by value, where any of the primitive types, strings or numbers, it'll compare the value of it and tell you that they compare if they're both the same value. Whereas for objects, they have to actually point to the same exact object. So the example he's got here creates 2 empty objects and then compares them to each other, but the result is false. And the result is false because it's pointing, each one of them is pointing to a different empty object. They're not pointing to the same actual location. Whereas when you compare the first object to itself, that comes back as true. And then the sort of inverse or whatever, the example using the primitives is 2 primitives that are assigned 1, 2, 3. When those are compared to each other, it comes back as true because it's actually comparing those values against each other. It's not just looking and seeing if they refer to the same reference or instance. Questions on that? Confusion? You guys have to be the quietest class I've ever had. All right, so getting into some more of the different stuff that we're working with here. Primitive values. The following are all of the primitive values, or primitives for short. You've got Booleans, true and false, numbers, and numbers, there's no implicit distinction in JavaScript between integers and floating point numbers, the same way that there are in some other languages. So all numbers are a number. You have strings, and then you have undefined and null, which are sort of these magic types and have special meaning and are incredibly confusing why it has both of them. So when we're talking about these primitives, they're compared by value, as I was just saying. So 3 equals 3 will always return true because they're compared by value. And we can see that, you know, it's easy to see. And just to verify that that's not true for objects, if we just did 2 blank objects and compared them to each other, it's false. And that's because those aren't compared by value. Question?
Does that object get, like, you really go deep into the object, it's kind of like a key? Or how are they, why are they not the same?
Why are they not the same? Yeah. So if you're thinking about it in memory, what's happening in the actual system, if you will, and in this case, I didn't give them names, so let's just call them foo and bar as if I assigned them names. And I did some empty objects. So let's have a big chunk of memory here. And I'm going to create an empty object for foo. And what that's going to do is take a chunk of this memory, however much it needs for a little empty object, and sort of put that object there, right? So foo refers to this. And then if I'm going to do the same thing for bar and create a new empty object, it's going to create an empty object and point to it at some point in memory in your system. And then when it compares foo and bar, what it's actually comparing is not what's in these locations. If instead you were to think like, let's number every location in memory. So let's start at 0, because we're programmers, we're crazy, and we start all of our counting at 0. And here we've gotten to, I don't know, 42, that's memory location 42. And here we've gotten down to 1076. And so bar was created at memory location 1076, and foo is at location 42. One way to think about what's going on here is if you're comparing these two, it's saying, oh, is memory location 42 the same as memory location 1076? And when it comes back, I mean, that's not true. So that's why that comparison is false, because they're not actually pointing to the same location in memory. And that's where it's a little different when you're working with primitives, because instead of, in a sense, comparing these memory locations, if we had, you know, hello, and in there it had the string hello as opposed to an object, and we had bye, and that pointed here, and because we're evil, we say hello again when we leave. Those can actually be pointing to different places, but when it compares these, it actually says, oh, I've got a string here and a string here. Are those the same value or not? and compares against those actual values at that level.
Hey, Jared, do you, sorry if I'm jumping the gun here, but you discussed the double equals versus the triple equals?
We have in the last class, and I didn't check and see if he covers that in this, but we can go over it real fast as well. So yeah, JavaScript for equality, I think it's a good point because we're doing a lot of equality comparisons, so I should probably review that. JavaScript does have something that's a little different than other languages too, which is it's a very loosely typed language. So it tries to determine typing at the last point possible. In other words, let me give you a comparison real fast. You guys haven't written in a lot of other languages, so you wouldn't be familiar with this, but in say Java, if you were creating an integer, instead of doing var, you would declare your variable with like int num equals 42. And that's telling it at the point of declaring that variable, this thing has an integer in it. And that's the only thing that's allowed to go in num. You're never allowed to. So if later in our code in Java, you tried to say num equals, you know, the string 42, for example, this would cause an error in the program because you can't do that. Now, if we switch this over to JavaScript, probably should have said Java and JavaScript for confusion aspect, but you switch this to JavaScript, var num, you do var, and so it doesn't know what type of value is in there, in a sense, until you're checking to see what value is in there. So you can have num equals 42 as a number, and then later you could reassign it to num equals 42 the string, and it doesn't have an issue with that. Doesn't complain, it has no problem with that whatsoever. And partially because of that, although it's not a requirement, they also have two different types of comparisons that can exist. And it really only matters for the most part between strings and numbers. There aren't a lot of other places where you encounter this, but it has double equals, which you haven't seen me writing right now, and then it has the triple equals comparison. And double equals comparison will convert from one type to another to try and see if the values are the same. So if you said 42 equals quote 42, well, this is definitely a number, and this is definitely a string. So it should be that this isn't true, because how could you compare two different types? But what JavaScript is actually going to do, since you're just using the double equals, is going to look at this, say, oh, we want to do a number comparison. So I think I could double check that, but I think it will base it off of whatever is on the left side in terms of what it's using as a comparison, the type. And then it'll say, oh, can this be a number then? And it'll convert this to a number and then compare that way.
Kind of makes a decision.
Yeah, it tries to ignore type as much as possible. So the double equals is an attempt to keep that super late type binding going on, so that, oh, I don't even care if they're the same type. I just care what they output is the same. So this would be true, whereas with the triple equals, it's saying do not convert type no matter what. And so this one would be false, because it's not going to do the type conversion between the two. And that's something that you'll probably get tripped up on at some point when you're writing code. You're gonna make that mistake. So yeah, I mean, it ends up like this: 42 equals 42. The string is true. Whereas if we tried it with triple equals, it's going to be false. But if we did something like this, 42.2 string think this will work. Equals 42. Two strings aren't going to work. All right. What? Let's see if this works. Okay. I just needed to have it in a variable to get access to that. So I'm going to do foo, and let's show that this triple equals 42, the string is false, right? But now if I do foo.toString equals 42, we get true. And you could think of that double equals as doing something very similar to that. It's trying to convert from one type to the other if it can.
There's another one, right? Another comparison
What do you mean?
method, like to check if they're actually working. That is not one. Another comparison to check if they're equal. So the triple equal. Like he's equal.
So some objects may have that on them, but I don't know if it's built into the language on anything. Let me check this real fast. Yeah, I don't think it's not even built directly into objects. So there's a lot of nice libraries and other things that will give you those capabilities, and it may be built onto some of the different types that exist, or some of the more complex objects. I'm not certain, but it's not. I don't think it's sitting at the top level. I could be wrong though. All right. Any questions right now? Keep moving through this. We'll see how far we end up getting for all of our review. All right, properties. So talking more about properties or primitive values. Properties can't be changed, added, or removed to these primitive values. So if you have a string, you can't add or change these properties on a string or a number, the actual primitive type. And that's because they're just sort of built into it. They're primitive, unlike your objects where you can add or change or alter whatever you want on your properties on them. Does that make sense? A little bit. So we can, I mean, an example of that, right, is basically what it's saying is we have foo, it's just 42 or whatever. And so I can't do like, this may work actually, it depends on how it's storing this, we'll see. So, you know, we're used to assigning a property that way, right? I can just create a property, like say .bar and give it a value and then read it out. But you can see here, it didn't work. When I tried to read it out, it told me it was undefined. 42 is a primitive type, it's just a number. And so I can't add properties to that. I can't add additional properties onto it or change the value of any of the properties in it. If instead I change foo now, and now I'm going to have it hold an object, and I add a bar property, and then I read it. Now I can manipulate the properties on an object. I can add properties and remove properties and work with it, but I can't do that on those built-in types, the primitives. All right, objects. Objects are one of the main things that we built to in the last class and started working with. So JavaScript has very loose ability to create objects. The simplest most straightforward way to create one-off objects is just known as the object literal syntax. We use this a lot in class. And that's just creating an object with these curly braces and then giving each property its name, a colon, and the value for that property, separating each one with a comma. So this is an example of creating just a simple object with two properties of first name and last name. People remember that? You feel comfortable with object literal syntax to just create objects? Yeah? All right. Seen some head nods. Good. And then array literal syntax, probably even more comfortable with this. We were doing this well before object literal syntax, right? You're just creating an array, you use square brackets instead, and then you just put the items for the array in there separated by commas. We didn't really cover regular expressions, and I'm sort of going to skip over them again here. I don't think it's something that you guys probably need to work with at this point in time, as they're really powerful, but also a little confusing when you first encounter them. So I wouldn't worry too much about working with regular expressions. So I already talked about most of this. Objects are compared by reference, not by value. So when you're comparing two objects to each other, it's comparing whether they point to the same location, not to the actual value for them. And as we just saw, objects are mutable by default. You can change those properties of objects, which is something we never really got into in the last class. We probably won't get into here either. The ability to lock down whether or not properties can be changed or altered. But you can add properties onto your objects very easily. And then the last sort of types, and all these are still these primitive types, are undefined and null. And these are just sort of the confusing types is what I call them. But JavaScript has two non-values, undefined and null. Undefined means no value. So uninitialized variables are undefined. So if you've written like var foo, foo is undefined at that point because it hasn't been initialized to anything. And any missing parameters, if you try and call them like we just did on foo.bar when we had a primitive and we couldn't add a bar property, it was undefined is what it returned because it was missing. It's not there. Null means no object. There's nothing actually there, not that it's like undefined. So these can be a little confusing. Most of the time when you're checking for null or undefined, you're writing an if like this. You're sort of checking against both of these values. And there's a variety of reasons why you sort of check both, but a lot of times you're checking both. And if you're writing something like that, you can also, this doesn't always work because of truthy and falsy, but you can sometimes be lazy and just do a not x or x, because null and undefined are both falsy values. So that means that they're like false. The only areas where you can get in trouble with something like this is if, say, you're working with numbers and 0 is a valid value for the number. Well, 0 can be falsy too. And if you're using this as a guard, if you will, so that you don't run some code if it's null or undefined, that code also wouldn't run if your value was 0. Any questions so far? Okay. So type of, you guys should be familiar with this too from class. Type of is just what you use to check what the type is of a value. So it returns a string, and here's the different strings it can return. These look very familiar, right? Undefined. The interesting thing is if it was null, you get back object, which is a little confusing. So you can't just rely on that immediately, but Booleans give you Boolean, numbers give you number, string, string. Function gives you function, even though that's a little bit of a special case there versus just being an object. And then everything else returns object. Instance of is don't know if we did a ton with instance of in our last class, so it may be something that's not quite as strong in your memory, but it's a really useful tool when you start working with objects more strongly, because instance of will tell you if it's an object created by a specific constructor. So the examples I have here, right? If we've got a bar constructor, we do new bar, and we check if B is an instance of bar, it's going to say true because it's, yeah, it was created by that constructor. It's that type. And then the curly braces, this sort of empty object. Is that an instance of an object? Yeah, because the curly braces is shorthand notation for using the object constructor. And the square braces instance of for array is true because array is a type of object, and that's a shorthand notation for creating an array. Any questions about that? That should be, and I may look foolish here. I like to try stuff live just in case, you know, it's wrong, and then I get to be completely wrong. That should be pretty much the same as if we ran code like this. If we did foo equals new object, foo instance of object should be true. And that's pretty much the same as some sort of Russian object, I don't know. Still type it wrong? What's wrong? Maybe it doesn't like that. Syntax after all. I don't know what's wrong there. We should see the same if we do this again, at least, right? So that's another indication that those like the square brackets for an array or the curly braces for object, that's just a shorthand. It's just a lazy way of doing it. Instead of having to type new object or new array, you can use this shorthand to just put some values there and call that type. All right, it does go into Boolean a little more here. People feel pretty comfortable with working with Boolean expressions and operators. And we've already been working with them at this level. Anybody really want to go over Boolean in JavaScript? Or we'll skip through this section.
Your example of the negation operator.
The
Not equal and not equal.
Yeah, sure. So
Use an example, like what's the best?
negation, so there's essentially three different ways syntaxes for negating something, right? There's just not, which is this bang by itself. So if I did not true, false. And if I did not false, I get back true. So there's no such thing as half-truths. And so all that does is opposite truthy expression of what you put in. And that's sort of what that bang is, what that's commonly referred to, is the same syntax you use when you're comparing stuff and you want to see if things aren't equal. So you could do if true is not equal to false, that's a true statement. So you can imagine replacing one of your equal signs in our comparison with a bang is a way of getting back not equal as opposed to equal. So if we wanted to do a tight insensitive comparison, if we did 42 is not equal to 42, that's going to return false, because in a type insensitive comparison, those are true, those are equal, and then it negates that result and gives you back false. And if instead, like I said, you sort of replace one of your equals with it, so if we did it with 2 equals there, that's going to say true because those are not the same type. So that before it does the negation is false, and then it negates it to true. Does that make sense? You end up using it a lot when you're trying to see if something, I mean, a lot of times you might be like, is this not null or not undefined? Or you might be checking if something is not specific values, like 0 is a common case if something isn't 0. I say, I don't tend to use the not equals quite as much comparison, but I do use the negation, just this a fair amount. And that may just be me, but I tend to write it more that way because I like to have more of my expression be, I don't want to have to try and think about flipping it in the middle of like, oh, if this was true, now it's false. I like to do it step by step as I'm walking up. And so if I were to try and write this same statement, this like 42 does not equal string 42, the way I would write it usually would be more like this. And that way, when I'm thinking of just, does 42 the number equal 42 the string? Okay, this is a type insensitive comparison. Yes, they do. And then I can step out to the next step and go, okay, now make the result of that false. So I tend to try and break them out myself, but you don't have to do that. That's just so I can think about them step by step and piece by piece when I'm working with them. Trying to think of other just really simple examples when you use them. I mean, you're going to use like not true all the time. You use it in React pretty heavily when we start getting into React, because you'll be making decisions where you say, ooh, if I have a value, then show this, otherwise show this. Or you may say, if I don't have a value, then return nothing from my function. I don't want anything to render, otherwise return something. So some of the other operators, we've got your binary logical operators. Those are the ands and the ors. So that's how you can combine multiple true and false statements to get a larger one. We talked about the prefix. We talked about the basic equality operators. And then you have your comparison operators as well, which sort of fall in that same vein. But you're not going to have type coercive versions of the equality operators. That only really exists for the equality ones, not for these ones down here that are greater than or less than. And then truthy and falsy, sort of the sort of tricky things are things that are false or falsy that might trip you up in your code at some point. Undefined and null. Boolean false. Okay, well that makes sense. Of course that should be false. But the number 0 is falsy. So just reminder of that is if you did like false is equal to 0, you'll get true. And that's doing a type conversion there between 0 and false. Now if I did false equals 0, that's not true because they're not the same type. So that's going to trip you up in your code at some point, most likely, where you're checking against false for some reason, but you forget that 0 can be false. And also an empty string is falsy. And so if you're comparing and something can have an empty string, your code may not work the way you expect. But sometimes you can use that to your benefit as well, right? An empty string should be falsy. So if I make this an empty string, it'll follow the path I expect for false. Besides that, everything else is true. People remember the short circuiting idea of how these binary operators work for and or? So this is just a useful trick to remember, which is that it never actually evaluates later steps if the first step satisfies the entire result. So if you're doing an or, for example, and remember the OR is sort of this double pipe, and the first portion is true, then it doesn't even have to evaluate later pieces. An example of that is, I don't have a bar function. We can see it's not defined. It throws an error if I try and execute this bar function right now. But if I wrote true or and tried to evaluate bar, what I get back is true. And it didn't throw an error because it never actually evaluated anything after that first true and this or, because it said true or, oh, true. Well, I'm already true, so I don't need to do any more work on this line of code. And the same is true for and, except obviously and works a little differently because it has to, if anything ends up being false. So if I tried that same thing with and, it's going to have an error because it says true. Okay, that's true. And oh, is everything else in here true? It has to keep evaluating, right? But if instead I did false and bar, it just returns false immediately because it says false and, oh, I already know I'm false. I don't have to run any more of the code on this line. And it's just known as short circuiting, and it's a pretty common thing to encounter where you do a complex example. Let's say we have a complex object. So do we still have our foo object? Yeah, it doesn't have anything on it. So let's say theoretically you could have a foo object, and then we have a bar property, which is an object. And so now we have foo and bar, and we're getting a little complex. And let's say, sometimes in there you also have foo bar as a property. Maybe not all of this has been built yet. Maybe there's, you're still creating this object structure in your code at some point in time. So you may have some logic that says if foo and foo.bar then do something. Yeah. Console.log foo.bar.foobar, right? And there's a problem here because it won't exist. It tells me undefined. But it didn't cause an error because foo and foo.bar existed. So now if instead I get rid of, let me try here. Let me get rid of foo.bar. So now I just have foo. And if I don't check, for example, for this stuff first, and I did foo.bar.foobar, I'm going to throw an error. And it's telling me I can't read the property foobar of undefined. Because when it tries to parse this, it says, okay, foo is an object, that's fine. But there's no bar, that's undefined. So undefined can't have foobar. And so in order to protect me from potentially having that error, instead, I could wrap it in that if that I just had. So I go back to my if and I say if foo and foo.bar console.log foo.bar.foobar, and it just returns undefined because that initial if sort of protected me. It said, okay, foo exists. Oh, but foo.bar doesn't exist. So kick out. And that's an idea of using this sort of ands to create a guard. And I only did 2 layers, but sometimes you might go down even more levels than that when you're guarding against some sort of object structure. All right. Let's take a short break. We can have a break. Be back in 5 minutes. If you're gonna go anywhere, I'm gonna step out for a minute, and then we'll keep going through this. Going a little slower than I was planning, so we'll see where we get, and we may or may not get to getting into NPM and package managers today. We'll see.